A spring is 20 centimeters when 0 newtons is applied to it. What is the spring constant if 25 newtons stretches the spring to 28 centimeters? Now this is actually a review question, because if you look, it actually has nothing to do with energy whatsoever. What we're trying to do is we're trying to figure out what the K value is. And normally, so far, we've been saying, okay, P equals 1/2 K x squared. And of course, we could do that. But really, there's another way of being able to solve this that works just as well, and that's this. We learned earlier this year about Hooke's law. Okay? And Hooke's law said that F equals K x. Okay? And we said that any sort of force that's applied will stretch a spring out depending on the value of the spring constant. So it says a spring is 20 centimeters when 0 newtons is applied to it. So now when it's 28 centimeters, we know that the x value is actually 8 centimeters. We know we don't deal with centimeters, so it would be 0.08 meters. We know that the force value is 25 newtons. And we can solve for it using Hooke's law. Hooke's law basically says 25 equals 0.08 K. Divide both sides by 0.08 and you get 312.5 newtons per meter. So now we talked about the experimental origins of Hooke's law at the beginning of this when we talked about force. But you can actually get Hooke's law using conservation of energy. And I will leave that to you to see if you can figure out how to get this from some sort of variation of conservation of energy.